Transformer Model. Attention All You Need by Ashish Vaswani in 2017. Natural language processing with its self-attention mechanism. Positional encoding. Input receives words, and words then converted into vectors of x dimension. An example like 768 dimension. Hence each single word expressed with vector of 768 dimension. Positional encoding receives these vector, and it adds the sense of position to the input embedding. Certainly, positional encoding in the transformer architecture provides the model with a sense of position or order of words in a sequence. Positional encodings are added to the embeddings of words. They're designed to be added to the word vectors without drowning out the original meaning in the embeddings. Multi-head attention. It comes under encoder module, which is created of multiple layer of multi-head attention and feed-forward module. A word or token represented by the vector example the four-dimensional vector as shown in the screen. Its attention score is calculated with all other words, that is the dot product with all other token vectors. More the attention score, more the word is related to the other word like student and book, taught and book shown by the orange line in diagram. This resultant vector now represents in the context of the entire sentence. For each token, this process works in parallel. Feed forward. Its basic purpose here to introduce non-linearity in the system, mainly by the activation non-linear function ReLU. For negative output is 0 and same number for positive number. Why it's required? So that model can learn more complex nuances. Real-world data is complex. Sometimes there is not direct relation between input and output, hence non-linearity helps to understand complex. Process. Output from multi-head attention, linearly expanding it, applying ReLU, linearly compressing it to its actual size. Without FFNN, it could not model the complex, non-linear relationships found in real-world data. Masked multi-head attention receives its previous output as input, hence called self-attention in decoder module. Multi-head attention and feed-forward, also called cross-attention in decoder module. All generated content pass through this layer so that the generated content keep attention on all the input by encoder, so that the reply it generates is in the sync of prompt. Hence self-attention to keep in sync of itself, and cross-attention to keep in sync of given prompt. Output from here is fed to feed-forward neural network, FFNN. Feed-forward working is similar as in feed-forward slide. Linear. The output of the feed-forward neural network is the number of previous generated vector. Taking the last vector, multiply it with projection matrix will generate a matrix of dimension of total number of token available called logits. Suppose the word is like I love to drink cow's milk, and prediction reaches up to I love to now. In the input to self-attention, 3 vector passed and output is also 3 vector. 3 vector passed to cross-attention layer output is also 3 vector. 3 vector passed to FFN and output is also 3 vector. But when passing to liner out of this 3 last vector is passed that is vector of 2. This vector is multiplied by projection matrix, which generate a new matrix of dimension of total token size E30,000. Suppose total number of token to be generated is 30,000. Logits equals an example shown on screen. Logits represents the score to the token. More the score, more chances of that token to be selected as next token. Thank you.